In this video, we're going to take a look at what's called simplifying rational expressions. And in general, what that's going to mean is we are going to reduce fractions that involve algebraic expressions. So we're going to see coefficients, we're going to see variables in the mix too. And we're going to start with some of the basics that we saw in middle school, but then we'll end up getting to the factoring we've been practicing when we get to our last examples today. And in that factoring, we're going to talk about these steps again, but we're going to look for something called a greatest common factor, a GCF for short. That's something that two or more terms have in common. And then after we check for that, we're going to talk about how many terms that we see, because when we factor, we're usually writing as expressions in parentheses that multiply back to what we start with. So we're going to look for how many terms that we have. If we see 3 terms today, we'll use the X method for split the middle. Or if we see 2 terms and we know the square roots of them. So if we see 2 terms, we're going to try using this formula that we've seen before, where the 2 factors are the same, except one has a plus and one has a minus sign. Okay, going to start off with the basics. Back to middle school really quickly. When we simplify rational expressions, these monomials, there's no plus signs or minus signs in these scenarios. So there's only one term in the numerator and denominator. A couple things. You've got coefficients that we need to reduce, just like we did in elementary school, actually, yeah. So thinking back to 5th or 6th grade, maybe, the coefficients here would be 14 and 7. So we have 14 in the numerator and 7 in denominator. With those, we just divide like normal. And that's going to just give us 14 divided by 7. In this case, we get a whole number answer of 2. And then we have these exponents too. So with the exponents, we do something different. 2 different rules, one for the coefficients and one for the exponents. And with these, we have a y value with an exponent of 10 in the numerator and another y value with an exponent of 4 in the denominator. And the rule for exponents when we are dividing is we subtract those exponents when we bring the y's together. Because again, reducing is giving us that smaller value. And 10 minus 4 is 6. So in our final result, our coefficients reduce to 2 and our exponents subtracted to 6. So our final result is 2y to the 6, a much simpler version of the original fraction that we started with. We can do that a couple more times here. We have 18 over 24. There's the coefficients on that one. So again, we need to reduce these, divide them, but 18 and 24 don't divide into that whole number or integer answer. So we can use calculators to help us, such as Desmos here. And if you type in 18 divided by 24, it's going to give you a decimal, but if you click the button to the side, there's your fraction, which is 3 over 4. So we have 3/4 here that we're using. So through the calculator, we saw that 18 over 24 is 3 over 4. Now, we also could have done that ourselves using simple division, dividing both parts by 6, and that would be another way to get that fraction. With our variables, same rule. So we have our coefficient rule. Here's the variables. So w, the numerator has a 3, the denominator has a 3, so we subtract those. That's going to give us w to the 0. And then last but not least, we have the x's. So we have 7 and 5. We're going to subtract those. And 7 minus 5 is 2. Okay, so all we have to do is bring all of this together. We have everything we need. We've reduced here. One thing to note is for the w, it does say w to the 0. That literally means that there are no w's left. But we do have a special rule that says that, well, if there's no w's left, what's still there? And the placeholder is always going to be a 1. So w to the 0, any value to the 0 is a value of 1. Okay, so there's no more w in our answer. We have a fraction that has 3/4. So I do know that my final result is going to have a 3 over a 4. And then we have this x with an exponent of 2. And we need to bring those together. And here's a little rule for us. If the exponent is positive, like this one is, this 2, that 2 is telling us to put the value in the top, the numerator of the fraction, okay? So with that positive value, we're going to the numerator of this fraction. So when I write this x squared, I'm going to put it next to the 3, which is also in the numerator. Okay, and remember there's no more w's left, so as far as reducing goes, that's everything we need. Going to the last scenario here, we've got example C. It's a lot like example B, coefficients, so 10 and 15. And then there's also two variables, so we'll work with those. So we have 10 over 15 that we need to reduce. Now with the x, watch out for this one. We have a exponent of 2 in the numerator, and we are going to subtract a large value away from it from that denominator. And that occurs from time to time, and we'll deal with that in a moment. For the y, it's still an 8. It's still taking away 3 from the denominator. So always the numerator minus denominator, top minus the bottom. Okay, now reducing again, we have 10 over 15. So just like before, we can type that in, 10 divided by 15, and see what that gives us. And we get this decimal. We convert that. It becomes 2/3. So we have 2/3 as part of this. So let's simplify there, 2 over 3. And then for the x's, we have 2 minus 7. So that's going to give us x to a negative 5. So we're going to talk about what to do with a negative exponent here. After that, 8 minus 3 is positive 5. So we have two variables and two exponents, but those exponents, one is a positive value, one's a negative. So here's what we're going to do. Anytime we see a negative exponent, the technical definition is reciprocal, which means to flip into the other part of the fraction. So when we see a negative exponent in this context, that's going to put this variable in the denominator for us. So when we write x in this problem, this x to the negative 5 is causing us to move x to the denominator of our fraction. And likewise with the y, it has a positive, so it's going to do the opposite. It's going to the numerator, like we already saw. So we end with all of that in 1. So our final result, reduced format, has 2 over 3. And then our x has been moved to the bottom of this fraction. So when we do that, that x turns positive, but the y becomes is already positive, so it remains in the top of the fraction, our numerator. So those are some basic things that we've practiced back in middle school. We still want to know how to do them, but we do have a little bit more. We're going to jump into some examples that have some factoring involved. But we are still looking for this idea of reducing, creating smaller fractions. If you're here in class, at this point, we did a little way ground activity for some in-class points, practicing these skills that we have right here. Now, if you go to the back page, we have 4 more examples, and it's just working on the factoring piece. These are all different because if you look at each of these, there's a minus sign in this one, there's a plus sign and a minus sign in the next one. When we get polynomials involved with plus signs, minus signs, we have different strategies that come into play. And those were the steps that we talked about at the very, very beginning. Okay, and those steps were still listed here. You can go back and check them anytime you need to. But with these, step 1 is kind of new to us. We're going to check for a greatest common factor. Okay, and specifically, if we only see 2 terms, okay, if we see 2 terms today, that's kind of the tip that you should be looking for this. Okay, so we're going to see if any terms have anything in common. After that, we have one of 2 choices. We'll use the X method where we have 3 terms and we have difference of squares back to when we have 2 terms. Okay, so we're looking for how many components our fractions have. Does our numerator have 2 or 3 terms? And we're going to have strategies for each. And then what's going to happen is we're going to cancel what's in common. A little bit easier to see that in action. So let's go ahead and go to the back here. And again, if I go too fast, just pause this video, rewind it as need to. But looking at number 2, we can see the numerator here has 2 parts. We have 5a minus 10. And with those 2 parts, what we are considering is when there's 2 terms, is there a GCF, okay? Is there a greatest common factor? There's 2 terms here. So with 2 terms, we're checking for a GCF, okay? And with GCF, what we're saying is, hey, you have 5a minus 10. Can you divide both of these by the same amount? And it turns out we can. In this particular scenario, we can divide them both by 5. And so that's what we're going to do. We're going to rewrite this expression 5a minus 10 as 5 times something else. And if you divide these by 5, reducing 5a divided by 5 is 1a, and negative 10 divided by 5 is negative 2. We are saying that we can rewrite our numerator as 5 times the quantity a minus 2. So I'm going to go back to this fraction here, and rewrite this as 5 with those parentheses. Great. Now the denominator, if you check it, the denominator just has one piece, one little piece. You can't do anything to that. So we're going to leave it exactly as we see it. And once you do this, what we are checking is there anything that these two parts of our fraction have in common? The numerator and denominator, you might notice both have a value of 5. So what we're trying to do is reduce and make smaller. Since there's a 5 in both locations, we can reduce those away because reducing causes a value of 1. So now instead of 5s in these fractions, we have 1s. And so what I can do finally is this last step here, rewrite this fraction with an a minus 2 in the numerator. We don't need the 1. That's 1 times anything is just itself. So we end up with a minus 2. We do have this 1 in the denominator, but remember, when we write numbers like 8 over 1, 8 over 1 is the same as just writing 8. We don't have to show a denominator of 1. So that's exactly what I'll say here. We don't need this denominator of 1, so we'll write the final result as a minus 2. Okay, so that is the overall goal, and not all problems look just like this one. This one's a more basic of the ones that we might see, okay? So for this one, we end up with just a simple expression of a minus 2 rather than everything we had in the fraction before. So looking at number 3, we have to just kind of look at one part at a time. When we look at this next fraction, the very first thing I'm looking at is how many terms do I see? So looking at number 3 here, we see 2y squared plus 8y in that numerator. And with that numerator, I see right away there are 2 terms here. And with 2 terms, we're asking ourselves, is there a GCF? Is there something we can divide by? And in this case, I think we can, right? Look at the 2y squared plus 8y. First thing that stands out is both of these can be divided by 2. They're both even. But you might notice this time, not only is there a number that they have in common, there's also a letter y. So we can bring a y away from each of these, okay? And so what we notice that they have in common is 2y, and then we ask ourselves, okay, if we divide 2y squared by 2y, the 2's cancel, we take a y away, we'll still have 1y after that. Over here, 8y divided by 2y, 8 divided by 2 is 4, sorry, and the y's are going to cancel here. So 8y divided by 2y is just positive 4. So that told us that we can rewrite this numerator as 2y times y plus 4. We can do something very similar in the denominator here. The denominator has y squared minus 16. So for this denominator where we have y squared minus 16 right there, we see it's 2 terms again, okay? So once again, we have 2 terms. But if we take a look at these and ask ourselves, is there a GCF? It doesn't appear like there is. There's not a number that we can divide in both spots other than 1. And we can check, do they both have a variable? And the 16 does not. So there's nothing that these two have in common. And when that's the case, but you have these 2 terms, the next question you need to ask yourself is do you know the square root of both? So when I check the y squared, do I know the square root of y squared? And the answer is yes, it's y. Okay, so then the next thing I ask myself is, do I know the square root of 16? And again, the answer is yes, square root of 16 is 4. And what that's going to give to us is a y plus a 4 and a y minus a 4 in this denominator. Because with the square root method of factoring, we start both factors the same, we end them both the same, but one has plus, one has minus. So 2 different types of factoring in that one. One where there's a GCF in the top, there was something they had in common. One in the denominator where there's no greatest common factor, but we knew the square roots. But every time you go through this process, in our practice examples, we're going to expect something to reduce. So if you are not getting parentheses, these factors that match, then we need to go back. We need something to match. We need to cancel something. And in this case, we have a y plus 4 in both the numerator and denominator that cancel away the whole thing, the whole quantity. And after you do that canceling, you're going to be left with 2y in our numerator and a y minus 4 in the denominator that we do not need parentheses for anymore. Okay, so those 2 things right there, a 2y and a y minus 4. Great. Now, There's just different strategies. We have to keep looking at how many terms we have, and we're going to carry that into these last two, okay? So check out number 4 with me. We've got x squared plus 9x plus 20. That very first expression has 3 components, 3 terms, and we haven't dealt with that yet today. So let's talk about what to do with 3 terms. And with those 3 terms, we split the middle when we use that x method, okay? So for that x method, in your x over here, we are going to need 2 numbers that do a couple things. They need to multiply to this last value of 20 is what we're going to need to multiply to, and we're going to need to add to this value of 9, okay? So we got a positive 9 right here. So we got positive 20, positive 9. Okay, so we need to find 2 numbers that do both. So with 20, there's multiple options. There's 1 times 20, 2 times 10, 4 times 5. Any of those multiply to 20, but the only ones that multiply to 20 and add to 9 are going to be a positive 4 and a positive 5. Okay, so for this trinomial in our numerator, since it has a leading coefficient of 1, we found the 2 values that we need for the factors by completing this chart. So our numerator is going to be an x plus 4 and an x plus 5 when we rewrite it. Now, what I'm hoping is one of these 2 factors shows up in our denominator. That's how we cancel. I want to figure out if I'm going to end up canceling the x plus 4 or the x plus 5. So we check that denominator and notice how many terms it has. Rather than 3, it has 2. So we have 2 terms down here. Okay, and with 2 terms, we always try GCF first. So let's check out, is there a GCF? Is there something I can divide them both by? So let's try. We look at them, they both have coefficients here, so we can divide by 2. They're both even. But there's not an x over here in the second term, so we are not going to divide by x. So the question is, what would I get if I divided by 2? So if we take 2x divided by 2, that gives us x. 8 divided by 2 is 4. And there we go. We are able to factor using GCFs. Now, if you're looking, remember we had this thing we wanted to happen. We wanted something in our numerator to match a component of our denominator. And notice we got the same factor of x plus 4 in both places. We need that to happen today if we're going to reduce. So it's good that we had something that matched. If something didn't, I would know to go back and check my work. But these x plus 4s are going to reduce, cancel away. And then our reduced fraction then is going to be what's remaining. So those reduce to 1. We have an x plus 5 in our numerator. And we have a 2 in our denominator. Okay. So that is all the types of factoring you're going to see. Greatest common factor, split the middle with the x method, or square root method. So let's put a couple of them together over here. Number 5, we have 2 things going on. Our numerator has 3 terms again. So let's think about what that means for us. If you have 3 terms, just like this one, that's the scenario where we use our x method. So let's go back to that again. We're going to split the middle here. The ending value, our constant, is 8. So we need 2 numbers that multiply to 8. And then our middle value, b, is -6. So we also have to add to -6, right? So we are multiplying to this top value. We are adding to the bottom value. Thinking through, if we're going to multiply to an 8, that means we either need 2 positive numbers or 2 negatives. Since we have a negative value that we're trying to add to, we're going to use 2 negative values. And walking through, values that multiply to 8 would either be 1 and 8 or 2 and 4. And for this particular scenario, 2 and 4 are what we need. The order of these 2 does not matter. Okay, we could have put the 4 first and the 2 second, but we did need these 2 specific values, a -2 and a -4. So our numerator is going to say those 2 things, x minus 2 and x minus 4. Either order is fine. But remember, I am hoping to get one of those 2 things underneath this fraction. I want to be able to cancel one of these. So when we look at our denominator, take a look at it. We first ask, okay, how many terms are there? And again, we see there are 2 terms. But with these 2 terms, we ask ourselves, is there a greatest common factor? And the answer is no. There's no coefficient with x squared here other than 1, and the 4 doesn't have an x, so there's nothing in common. So this is where, okay, you have 2 terms, but there's nothing in common. Let's use square roots to help us factor. So the square root of x squared is x, and then we'll find the square root of 4, which is 2. And so when we factor this, we have two sets of factors. We're going to have x plus 2 as one, and x minus 2 is the other. Remember, they both start the same, end the same. But that worked out perfectly because remember, we wanted to cancel one of these two things. We were hoping one of these two factors showed up in our denominator. And it happened right here. We have an x minus 2 from our split the middle process, our x chart in the numerator. And from our square root factoring, we had x minus 2 as well. And those two are going to reduce. So we're going to reduce the x minus 2's here. And so after we reduce, those are the only factors that we're matching. We are left with then our numerator, which had x minus 4, and our denominator, which had x plus 2. Okay, so again, go back, watch any parts you need. I can't show every single example of what you might see out there, but you can go through in each scenario that you encounter. How many terms are there? If there are 2, check for a GCF. If there's no GCF, try square root. If there's 3 terms, always and forever, use that X chart, and you should be able to get to those 2 factors, maybe with a little bit of work. All right, as always, feel free to reach out, ask these questions along the way. Good luck.